Students, so we are doing sequences in series, exercise 9.3, question number 16. Find the GP for which sum of the first two terms is -4 and fifth term is 4 times the third term. Okay, so sum of the first two terms, that is a plus a1 plus a2, is our -4. So sum is given by S2, sum of first two terms. Then the fifth term, a5, is 4 times the third term, a3. Okay, so S2 is there. Okay, from S2, from this you can find a gets cancelled here, right? a5 we can write a r raised to 4 equal to 4 into a r raised to 2. So r2, r square is equal to 4. So r is plus or minus 2. Okay, so S2 is given by a 1 minus r raised to n upon 1 minus r. N is 2. Okay. S2 is -4. A we don't know. R square. So 2 square. Okay. I'm taking here positive 2. Okay. This is for r is equal to plus 2 upon 1 minus 2. So 1 minus 2 is -1. -1 into -4 is +4. 1 minus 4 is -3. So 4 upon 3. -4 upon 3. Okay, this is for r equal to +2, r equal to -2. This is -4 equal to a, and -4 upon 1 plus 2, that is 3. So -4 into 3 upon -3. So 4. So we are getting a equal to 4 by 3 and a equal to 4. Okay. So we have to write the numbers in GP. So first is r is plus or minus 2. So for r equal to +2 and for r equal to -2. Here a is 4 by 3. Here a is 4. So GP for this is a into r, 8 by 3. A into r square, 16 by 3, and so on. Okay. For this a is 4, a into r, a into r square 16, and so on. Okay. Question 17. If the 4th, 10th and 16th terms of a GP are x, y and z respectively, prove that x, y, z are in GP. Okay. So A4, A10 and A16 are x, y, z. Okay. So A4 is AR cube raised to 9. Okay. Prove that x, y, z are in GP. Okay. So I'll divide first equation, second equation, third equation. So I'll divide 2 by 1 and 3 by 2. Okay. So this is r raised to 6 then 3 by 2, okay, so we are getting same terms. So from this, you can write y by x equal to z by y. Okay, so we have to prove that they are the terms in GP. So this is x, y, and z. That is, if you have terms in GP as x, y, and z, then their ratio should be y by x, then other ratio for this it is z by y, and ratios should be equal, and we have proved that ratios are equal. Okay, so the terms are in GP. Question 18, find the sum to n terms of the sequence. Okay. This is given. So we have to find Sn. So we have to determine first whether it is a GP or an EP. Okay. So GP, how you determine? You have to look for the ratio. Ratio is not similar. Okay. So this is not a GP. So if you add this, that is sum, it will be 8 plus 88 plus 88 plus dot dot dot. Okay. You can take something common, that is you can take 11, 12. Okay. 18 to 1, 18 to 11, 18 to 1, 1, 1, dot dot dot. So you can take common 8. 11 plus 1, 1, 1 plus dot dot dot. Okay. Now we can write this. We have to write this in terms of sum, right? So the terms should be equal, like. So we can write this as, I can multiply by 9 and divide by 9. So if I divide by 9 and multiply by 9, then this will be like this. So we can write this as 9 can be written as 10 minus 1. This is 100 minus 1. So 100 can be written as 10 raised to 2 minus 1. Then 10 raised to 3 minus 1. And so on. Okay. So we can sum this up. So it will be 10 plus 10 square plus 10 cube plus dot 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 minus 1 plus 1 plus 1 dot dot dot. So these terms are n terms, right? So we can write this as n, that is 1 is added n times. So this becomes n. Okay. And what about this? This is a sequence. That is, this is GP. This becomes GP. That is, if you take 10 square by 10, this will be 10. Then 10 cube by 10 square. ratio is same. Okay, so you can write the sum of these terms. So this will be a is 10, 1 minus 10 raised to n upon 1 minus 10. Okay, so this is what the sum of n terms look like. Okay. Next question, question number 19. Find the sum of the products of the corresponding terms of the sequence. So first sequence is given and this is second sequence. Okay. Now we have to find the sum of the products. That is, this you have to multiply and add to the second multiplication. Okay. So we have to take something common. So this is the smallest, right? This is 64. So look for 64 here, 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 and here. Okay. So here it is not there. Here we have to substitute for 64. That is, we have to make this 64. 16 for the. So into 4 divided by 4. Okay, so 64 I am taking common. This is 128. So it will be, you have to divide 64 to this and you will get 16 4. So 4 plus here it will be 2, 1. 16 for the. So 2 by 4 remains. So 1 by 2. And this is, again you have to make it 64. 32 into 2. So into 2 divided by 2. So 1 upon 4 remains. So 2 square. Okay, now you have to see whether this becomes GP or not. That is, you have to take the ratio. So 2 by 4, half. This is also half. This is also half. This is also half. So this is a GP. So you can write this using sum of GP. That is 1, 2, 3, 4, 5. 5 terms are there. First term 1 minus r is half raised to 5 upon 1 minus half. Okay. So 1 minus half is half. So into 2 into 4. And this is 1 minus 1 upon 32. 32 minus 1, 31 by 32. 32. Okay, so you can cut this 32 to the, then multiply 2 to the 4, 4 for the 16, 16 into 31, 496. Okay, next question. Show that the product of the corresponding terms of the sequences give a r raised to n minus 1 and ar square ar raised to n minus 1 comma gp and find the common ratio. Okay, so dividing will get the ratio. Okay, so dividing products. Okay, so product of this is a into the capital A. So if you take this second term, AR into AR upon A into A, we'll get RR. What about the second term? AR square upon AR square upon AR into AR. R square, not R square, this is R, R, R into R. So the ratios are same. Okay, so this is a G. Question 21. Find four numbers forming a geometric progression in which third term is greater than the first term by 9 and second term is greater than the fourth term by 18. Okay. So three numbers are there. 4. A1, A2, A3, A4. Okay. Third term is greater than first term by 9. Then second term is greater than fourth term by 18. Okay, these are the two equations we have. So A3 can be written as AR square. A1 is A plus A2. Okay, so we have two equations, that is AR square minus A is AR square minus 1 equal to 9. This is AR minus R cube equal to 18. So dividing will get, this is first, this is second equation by first equation, divide. Here you can take common R also. Okay, this you can cut, that is minus sign will come outside. So minus R is equal to 2. So R is equal to minus 2. Okay, substitute in any one of the equations. So I am substituting in this equation or this equation 1. 4 minus 1, 3. 9 by 3. So A is 3. Okay, so we have A and R. We have to write this for numbers. So A is 3. Second is A into R minus 6. Then A into R square. 3 4s are 12. minus 8 into 3 minus 24. Okay. Next question. If the pith, qth and rth the terms of the GP are ABC, prove that. Okay. So pith the term AP, A, AQB and ARC. So this can be written as A R raised to P minus 1, A R raised to Q minus 1, and A R raised to R minus 1. Okay, so here R I have to take something else. Okay. Now, okay, A also because here A is there, right? So A I'll take bigger A, capital. Okay. So we have to prove that minus RB R minus P C raised to P minus Q is equal to 1. This we have to prove. Okay. So if I take this starting with LHS, it will be A raised to Q minus R. So this in terms of this you have to write. Okay. A Q minus R, then R raised to Q minus R minus 1. That is we are writing AQ minus R. This raised to, that is A is our A R raised to P minus 1, correct? So we are taking A raised to Q minus R. So this will be A R P minus 1 raised to Q minus R. Okay. So it will be A raised to Q minus R into R raised to Q minus R into P minus 1. Like this. Okay. So I'll write here directly R raised to Q minus R into P minus 1. Then we are taking the second term B raised to R minus P. So this whole raised to R minus P. Then the third term C raised to P minus Q. Okay. So like this it is. Now we can write A raised to, we can sum it up, right? That is A raised to M into A raised to M. M is A raised to M plus N. So we can add this. So A raised to Q minus R plus R minus P plus P minus Q. Also for R, okay, R you keep as it is. We have to multiply this inside. So it will be QPQ minus Q minus rp plus r. Then again this multiplication minus pq plus rp minus r plus p. And this multiplying pr minus p minus qr plus q. Okay, you can cut the similar terms. Plus q minus q. So rp minus qr remains. No, it should be 0 because we want 1, right? So some term, second term is pq, rq. Okay, this is rq. This also gets cancelled. So this is 0. This is also 0. So we are getting a raised to 0 into r raised to 0, which is 1. So this is our RHS. Okay. Next question. If the first and the nth terms of a GP are a and b respectively, and if p is the product of n terms, prove that. Okay. So first term is given a, and nth term is given b. P is the product of n terms. Okay. Prove that p square equal to ab raised to n. So the terms are ar, ar square until n. Product will be a into ar into ar square till arn. Okay. So this is a into a, that is a raised to n, into r into r square into this. This will be r raised to 1 plus 2 plus till n minus 1. Okay. Now we can use here AP. That is this sum, that is this sequence is AP because the difference is 1. Okay. So using the sum in AP, you can add this. So addition of this I'll write here Sn. Sum in AP is given by n by 2, 2a plus n minus 1 d. N is n minus 1 here. A is 1. N minus 1 minus 1. And d is 1. So this is n minus 2. This is n into n minus 1 upon 2. Okay, so this a raised to n, r raised to n into n minus 1 divided by 2. This is p, and we have to show that p square is equal to ab raised to n. Now first term is a. So this is, if I square this, then this becomes 2 raised to n, r raised to n into n minus 1 upon 2 into 2. So this 2 gets cancelled. Okay. n is common to both of this, so we can write the whole raised to n. Okay. This I can split, that is I can write a into r raised to n minus 1. Okay. This is nothing but a is the first term, that is given a only. A r raised to n minus 1 is the last term, so that is b. Okay. Question 24. Show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1 third to n third term is 1 upon r raised to n. Okay. Sum of first n terms of a GP. Okay. So sum of first n terms of a GP is a 1 minus r raised to n upon 1 minus r. Then they have taken sum of n plus 1 third term to 2n term. Okay. So sum of this is given by first term will be n plus 1 third term. So a is a n plus 1. 1 minus r raised to 2n. Okay. So the ratio of this we have to calculate. Ratio of this to this. So it will be this is in denominator, so it will come in the numerator, this will be in the denominator. Okay, so here this is 2n, means from here to here the terms are n. Okay, if you have, say for example, 10 terms are there. Okay. So sum of 10 terms is given like this, 1 minus r raised to 10. Okay. Now again, if you are calculating from 11 to 20, okay, then again these terms are 10. Number of terms are 10. We don't write 20, right? So here also there will be 10. So here you have to write n only, not 12. Okay. So you can cut this a upon an plus 1. Okay. Now an plus 1 term you can write it as using GP a r is to n minus 1. So n plus 1 minus 1. So this will be like this. So 1 upon r is to n. Okay. So this is the ratio.